In this presentation, I'm going to talk about how I transformed teaching in calculus courses with cutting-edge recording and editing technologies. And this is a joint work with Dr. Gerstenschlager and Dr. Zhang. And to be honest with you, it wouldn't be possible to present the content in this video through a Zoom meeting because I'm using lots of demonstrations and videos. It wouldn't be possible to wrap everything around. All right, let's get started. All right, before I dive into our research, let me just give you some background information about calculus classes. In particular, Calculus 1 is the most fundamental course for college level science, technology, engineering, and mathematics, as we know, STEM intended majors. And in the fall of 2010, there were over 300,000 students taking Calculus 1 across the USA. That's a whopping number. And the fact that US colleges and universities are struggling with the high attrition and failure rates in calculus. And soon after this was diagnosed, there was a national study of college calculus conducted by the help of NSF and MAA. And it's observed that success rates in Calc 1 are very low for traditional students, but that wasn't the biggest problem. It's even lower for non-traditional students involving women, students from underrepresented minorities, economically disadvantaged students, and obviously first-generation college students. And 2 years after, MAA and NCTM, the National Council of Teachers of Mathematics, released a joint position statement, and the main theme of that statement was all about that students coming from high school are simply unprepared, and then they were forced to rush through the mathematics curriculum, and they're trying to compensate in the college for what was missed. And more importantly, again, it's underlined that the retention rate is fairly low in calculus courses. And one part of the report was shocking, other than the statement here, that students expressed concerns about the insufficiency of the information covered in the course and lack of opportunities to practice the material. All right, from the National Study of Calculus, let's try to zoom in to my calculus courses. And before I dive into that, I should probably state that I've been teaching calculus since 2001, and I've been collecting data through formative course assessment surveys since 2011. So I have a bunch of data collected so far, and the main issue that I'm going to show you today is just one of the lots of issues that I have experienced so far. And the question in the survey was, what could the recitation leader have done differently to improve your performance on the quizzes? And this is, by the way, regardless of the TA or regardless of the performance of the TA and regardless of the audience you teach. And more examples in the recitation, more worked out problems, and more non-trivial problems to be gone through during the recitations. So it looks like there's a lack of practice going on across all calculus sections. And here's the reason, because we teach Monday, Wednesday, Friday as instructors in lectures. You have only several problems, maybe one or two problems, in fact, to be gone through to apply the abstract concepts. And these are mostly chosen to be trivial problems to get the ideas across, at least. And well, we have 2 to 4 sections per week covered in calculus classes, and then in total we must cover 28 to 30 sections in Calc 1 and Calc 2. And more importantly, we obviously assign homework problems, and in every homework assignment I have personally 8 to 15 questions to practice the skills for the predetermined course learning objectives for each section, right? And then average number of questions gone through the recitations is 2 to 4 per section. And again, this is not really changing from one recitation to another or one TA to another, but this is happening all the time. And what is our take in solving practicing the calculus content problem? And first of all, you have to plan big. In fact, you can't make this plan during the semester. You have to sort of like plan ahead. And first off, I have started writing the learning objective in a very solid way for each section, and I determine the skills necessary to achieve each learning objective. And once you determine the skills, then you pick the good number of relevant exercises, not necessarily just from trivial ones, but trivial to non-trivial ones to practice these skills. That's why I choose between like 8 to 15 homework problems in each assignment, because let's say there's 3 to 4, maybe sometimes 5 learning objectives, and for each learning objective I try to have 2 to 3 questions, 2 to 3 exercises for my students to practice. And to be honest, recitations are good resources for practice, but the time and the number of exercises gone through during the recitations are very limited. Remember, recitation leader has to cover 2 to 4 sections in 2 different recitations, Tuesday and Thursday. So you can see how big the problem is. And one part of the deal was to develop a good format of, in fact, accessible lecture and recitation notes. And I wrote most of my notes in Beamer, LaTeX, and also PowerPoint. And the design, color, graphical aids are very important because there's a lot of visual learners, and I'm a visual learner, and if there's just simple text written in the lectures, it's hard to understand. So and for that reason, I tried developing Wolfram or Desmos demonstrations to apply each abstract concept to homework problems. And I also designed simulations, 2D or 3D visuals, whenever it's applicable. This sort of like transformation takes time because we're definitely going into digital in the following years, and you have to start planning big. And demonstrations are really important, and simulations as well, because so many abstract concepts are not getting across at the student level in terms of student understanding. So demonstrations are really helpful in terms of letting students visualize what those abstract concepts are related to. So now the question is that you have all these nice resources, and how are you going to blend them into videos so that you have more effective videos when you lecture? And if you're teaching at WKU, you have 2 options. One obvious option, is to have an appointment from the professional studio of CITLs of WKU, and let them know that you would like to record your lectures or recitations over there. And what they do is, like, you see the picture of the tech specialist Andrew Swanson, and he has a green screen technology and a light touch board technology. So when you go there, I'll show you a few examples of that within my videos, but when you go there, you have a glass screen, and then you can actually write on the glass screen by special markers, and he helps you with the setup of those. But other than that, you have to sort of like make sure that you have your PowerPoint slides, PDF files, simulations ready, and double check before you show up at the studio, because whatever the softwares, whatever the application you use may not exist in your computers. So you can bring your own computer and you can edit certain things, but it's super hard to make changes at the studio. So you have to sort of like go there super prepared. And it may also take several hours to record your best shoot. There's going to be a lot of trial errors. So just be prepared. At least try to have a time slot for like 2 hours at least if you want to record something for 20-25 minutes. And what happens is that CITL doesn't provide professional editing of those videos due to obvious reasons, because they're understaffed, and there's not really a professional editing person being present over there. So you're mostly on your own in terms of professionally editing your videos. All right, let me just show you what I did in the recording studio. Let me just play those. And as you see, I can fast forward here. and see like there's a glass screen, and you can just sort of like mark on the glass screen, and that reflects back on us flipped, as you see. There are various stuff we use. And this is what you do at the CITL's Professional Studio. As you see, like in each video, I solve a single problem or problems with sub-questions. So as you see that I have like 359 videos over there that involves lecture videos as well. But it took me, I started in spring 2019, and that was summer 19, and also some part of fall 19 I was recording over there. And every time I went there, I was my appointment was for 3 hours, and I was trying to go there like 3 times a week. So on top of teaching a lot of courses, I was going into the studio and teaching another 3 hours that day, and that's not the biggest issue anyway. And the biggest issue, I think, is the post-editing process I'll mention in a few seconds. And I'm not sure about if CITL is still accepting appointments after COVID, because all of the videos I recorded, that was like almost 250 something videos I recorded at the CITL's studio pre-COVID. So double check with Andrew Swanson. And another alternate is to have your own home studio. I think everybody's, having lectures already at home. So why don't you have a home studio, which is not that expensive as you may think, but you may need certain hardware, including green screen, a good computer, having a good display card, and a good processor as well. You may need multiple external cameras, wireless mics, and external monitors. I would say having a couple of monitors could be extremely helpful in recording. And obviously, this is not the only thing. You should learn at least one video recording software. It could be Cam Studio, VLC, or OBS Studio. And it's not the biggest portion that occupies recording, the amount of time that you spend for recording. And in fact, post-editing is more important than even recording. So that's why you should learn at least one video editing software, Windows Movie Maker, iMovie, or OpenShot, that you should be able to post-edit your videos and add effects and add in-between slides. You can add extra information, extra formula cards during the post-editing process. So you should learn probably one of those. And not to mention, you're going to have a big chunk of data. So you need to have a big storage space to store the videos and to share with your students. I would say like at least 1 to 5 terabytes of storage space is very essential. And now the biggest question: where are we going to publish those videos? How are we going to share those videos? And I'm not a big fan of MediaSite, and I started using my YouTube channel to deposit those videos in, because you're talking about 250 videos for restation, only for Calc 1. And for that reason, I came up with this channel, Math by Dr. Oz. I have been having that for a long time, though I made it more active in 2019. And I have all of my videos. Currently, I have around 800 videos, all dumped in my YouTube channel. All I do is just to recall them in Blackboard submodule, if you're talking about the lecture videos, and all the recitation videos are already built in my PowerPoint slide. So you just students just with one click visit the YouTube channel within a browser they have. It could be like a mobile phone, tablet, or a computer. It doesn't matter. YouTube is almost like platform independent. So, and then they start watching my videos. And here I forgot to say, like, you also need to have good lights placed in different parts of different sides of green screen. So light is in fact one of the main things that you should worry about. And all of these videos have been copyrighted, and right now I have over 700, but it's close to 800 at this level. And this was the first phase, by the way, of transitioning to traditional lecturing to a video, transitioning from traditional lecturing to a video platform by the worked out content. So I had privilege of doing that the first time at WKU by using the studio of CITL for Calc 1 and for Calc 2 after COVID hit, starting from March of last year. I had my own studio and I started recording up here. It wasn't an easy transition, to be honest with you, but soon after I got into the grooves of that, I was really fast recording several videos per day, recording, editing, and depositing them all the way to YouTube. And here is some of the content I had at my home studio. And as I said, these are all copyrighted videos. And again, these are all recorded at my professional recording studio at home. And I use an iPad Pro to be able to write on the screen. Let me just show a couple of them just to give you an idea. And all of the images and all of the stuff that you see here are prepared by me. I inserted a lot of demonstration projects here. A lot of visuals, 3D visuals. I mean, the ultimate goal here is to make the content more accessible by students. As you see, there's lots of explanations here. This is a demonstration project here, so there's a lot of explanations going on over there. And getting close to the end of that. And please visit Math by Dr. Oz to see all different kinds of videos and how I recorded those videos. And there's almost 300 videos available to public over there, out of almost 800 videos currently. All right, let me just talk about the data that we collected in Spring 20 together with Dr. Gerstenschlager and Dr. Xing. And we investigated the short and long-term effects of the use of instructors' videos, my videos, in student learning. And short-term means like from the beginning of the semester to the first exam, and the long-term is more like the whole semester. And we had two sections of calculus. One was the control group, and the other one is the treatment group. And for the treatment group, we provided all the videos for free. And for the other group, the control group, they had no access to recitation videos. Obviously, both sections had their own recitation leaders, but again, one section had like 250 recitation videos on top of the power of a TA. And our methodology, in the beginning of the semester, we implemented a calculus readiness test, and everybody took that test. And we were just seeing where they're placed in terms of how ready they are in calculus. And all sections are given the same exam number 1 and the same final exam. And here is the description of the data. So in the control group, we had 23 students, and in the treatment group, we had 18 students. And these are the scores of the readiness tests in the control and treatment groups. And exam number 1 averages you see in the third row, and the final exam averages. Again, all exams are uniform across sections. And I would say that I would probably not, I shouldn't be the person to talk about this data analysis, because Luke and Natasha worked on this statistical model, and it's called ANCOA, and it has certain assumptions. I don't have the expertise on what they have done here, but I'll just show you the results here. And the output indicates that there is no significant short-term effect. And p-value for the treatment effect was measured to be like 0.25. And the biggest thing is like the long-term effect was huge. And again, all the assumptions are satisfied, and there's a significant long-term effect with the p-value to be 0.02. And based on Luke's interpretation of this data, long-term effect was very substantial. So if students watch those videos in time with my explanations of certain problems with a step-by-step approach, their success rate gets higher and higher. For the treatment group, we also conducted a survey, and the first survey was given around the 4th week of the semester, and the other one was given around the 11th week of the semester. One of the statements that we asked for students to verify is that the instructional videos contributed to my achievement of the learning objectives for each section, and yellow got better, and students sort of like appreciate those videos, especially towards the end of the semester, matching with Luke's finding. This was the question that I wanted to ask because I have heard that students have lots of technical issues watching media site videos, but my videos are all dumped in YouTube, and as you see that there's no significant problem popping in terms of having technical difficulties watching these videos. And we also ask for the design, format, medium of the instructional videos. As you see that we got good satisfaction from the students. We have strongly agree and agree, popping all the way to 70% in fact, which is not bad. And the length is obviously very important, and I kept the length almost at the level of 3 to 8 minutes for each video because students tend to skip, as you may guess. And I see people recording like 60-minute lecture videos, and believe it or not, nobody watches them. Obviously, students love to see their teacher in the videos. You can see this from the numbers here. And there could be various reasons for students to watch those videos. It could be reinforcement of concepts, clarification, practice, review, and retention. So again, depending on these answers, you can, in fact, try adapting your lectures. And this result here may tell you about the length of the videos you design. Even the videos were like almost 3 to 8 minutes. Students tend to fast forward, let alone you have like a big chunk of 45-minute videos, nobody watches them. Just sort of consider this in designing your videos. Thanks for watching.
Yes. You mentioned there's a lot of editing, post-editing. What kind of software do you use?
I mostly use the OBS Studio, and I was able to use it in a very professional way that within recording, you can pause and continue recording. So if you're in the studio, if you want to stop, you just stop it. You just say stop. And then you have to restart the video again. That's going to be another piece of the video that you need to consider for editing after you're done with the shooting, you know. But when you do it home, I was able to pause whenever I want to pause and take a breath, you know, and then continue to my next, let's say 10 or 15 seconds of shooting. So OBS in that regard saved my life, because if I wasn't able to use OBS, then I wouldn't be able to, you know, have like an easy job of recording so many videos and editing them, because editing in the studio, that was a mess. That's why it took almost like a year for me to record and edit and publish them. But Count 2 videos, I was really fast in recording and editing because I did everything at home, and I used the OBS Studio for that reason.
How much does it cost for your home studio?
I got some sponsor, to be honest with you. Schungert sponsored some of that because I was recording for them. But I would say if you have a good running computer and if you can buy an iPad Pro for $750 and green screen, you see the green screen in the back. Normally, you know, so I erased that. But you know, light stuff and green screen, it wouldn't be more than $250. So I would say, like with the iPad Pro, you won't go beyond $1,500 to wrap everything up and get ready for shooting. I would say. Maybe it could be even cheaper than that, but you know, it's up to your budget. Yeah.
Right. Wow, that's very impressive.
Sorry about the.
Gosh, so impressive. Well, our next speaker is Dr. Richard Schungert. In today's talk, he's going to give us talk with the title The Calculus of Dr. Kessler, an ODE to our departing department head.
Thank you, Lucan. And so, really, this is to honor, Dr. Kessler's musical talents, problem-solving talents, and then ultimately, to say thank you for a good 8 years as our department head. And so, oops. Okay, anybody that writes word problems about their boss is crazy. And it's not in fact recommended. But if you're going to write a word problem about your boss, check with your boss first. Of course, I didn't do that. Make sure your boss has a good sense of humor. And then when writing, keep it appropriate. No Friars Club roast or anything like that. Prop up the talents of your boss and add humor. But again, keep that appropriate. And again, since we have a plenary speaker from Canada, add humor. And so why word problems? Well, it's my shtick. My favorite high school teacher shtick was wearing interesting ties like a film strip tie. And so I started writing in graduate school. I watched too many cartoons as a kid, and so at least I'm taking advantage of that today. Some of my favorite subjects when writing word problems include cartoon characters, especially SpongeBob. One semester I wrote so many SpongeBob problems that a student gave me a bobblehead SpongeBob, so you can imagine basically a square on a spring. I've also written lots of word problems about mascots, especially Big Red, and I occasionally use humanoids. Bernie Sanders and his mittens could be something. I could come up with something going forward. I've written very few word problems about faculty. The only ones I've written about are Dr. Kessler and Dr. Schungert. Going forward, I would check with faculty for permission. I really haven't given that a lot of time, and I really don't. I'm putting this in here to not. I don't want the faculty here to feel as though I'm going to be writing word problems about you going forward. I've thought about if I was going to write a word problem, it'd be something like like a take on the math plays that we've had during our previous math symposium. Okay, so how do I formulate the word problems? Well, different ways of doing that. Sometimes it's because of the topic. I wanted to write a word problem about a ladder being pulled up the side of a building, dragging on a ground. So I wrote one, about a ladder being dragged up the side of Pierce Ford Tower. Big Red was using a ladder to try to pull a prank or joke on the San Diego chicken. Unfortunately, he got caught, and so McGruff, the crime dog, catches Big Red. Well, shall we say, red-handed. I've surveyed honors classes for their favorite TV characters. One time I wrote a word problem about Hannah Montana and a conical pool party. It was toward the end of the semester. And so, by having a pool party, basically it was a way of being able for me to include all the TV characters that I had collected over the course of the semester if I hadn't included them in previous word problems. I also like to include catchphrases of the various characters. And so, Hannah Montana's catchphrase is sweet niblets. For this particular problem, SpongeBob jumps into the pool, starts absorbing the water, and find the rate at which the volume of the water is decreasing just before SpongeBob gets stuck. I also like to sometimes include pictures of places that I've traveled to. One time I had, SpongeBob tried to put a mustache on the Mona Lisa, but the ladder started to slide out from underneath him. SpongeBob swims into the Great Barrier Reef, destroying the ecosystem, and trying to find explanations for how the Venus de Milo lost its arms. And so I wrote one. At least I think I've written multiple ones on that. One of which was with regard to Marvin the Martian. I also like to write word problems based on a subject or experience as well. I've attended the CMA festival. One time I wrote a word problem about Big Red catching Hunter Hayes fever. Hay fever, Hunter Hayes fever, get it? Okay. I've also attended President Kimoni's address to faculty more than once. And one time Dr. Kessler performed at the address. And so I was thinking, can I construct a word problem about Dr. Kessler's musical talents? The answer to that is yes. In fact, more than one. And so we're going to see some of them now. As many of you know, I've given a number of talks on wound healing over the years, and on some of them I have a grotesque picture of a diabetic foot ulcer, and so it's typical for me to putting a warning slide before you see a picture of a diabetic foot ulcer. So first of all, no humans were harmed too much in the creation of these word problems. The same can't be said for cartoon characters and mascots. So, Big Red decides to attend the CMA Festival in Nashville. While there, he joins up with Big Schmo and Big Kenny from Big and Rich to form a new band titled the Big Big Trio. An hour before their first concert, Big Schmo and Big Kenny get laryngitis, leaving Big Red as the lone singer on stage. The graph on the next page has the total number of words Big Red sings over the first 60 seconds. What is the average rate of change of the total number of words that Big Red sings over the first 60 seconds? What are the units for the average rate of change? What is the average rate of change of the total number of words over the first 10 seconds? And how does this compare to the average rate of change over the first 60 seconds? After 60 seconds, Big Red passes out from the pressure. Fortunately, Dr. Bruce Kessler, WKU math department head, is at the concert. He steps on stage and saves the day by singing for 2 hours and receiving chants of Bruce, like Bruce Springsteen receives at his concert. And so here's the corresponding graph. And so again, on the y-axis, what you're looking at here is the total number of words, and on the x-axis is the time in seconds. And so what is the average rate of change over 60 seconds? It's really just the slope of the line passing through the endpoints in this case. And what we get is an estimate of about 0.65 words per second. Answers can vary depending on how you interpret this graph. Over the first 10 seconds with the yellow line segment, the average number of words is about 1 word per second. And so Big Red is singing more words during the first 10 seconds than overall. So that starts to decrease over the 60 seconds. The next problem, oh no, Quentin Gibson, lead guitarist, went on tour with Darius Rucker, slipped on a banana peel left by Big Red as he was walking to the stage to perform at the CMA Festival, but is now unable to perform. Fortunately, WKU math department head, Dr. Bruce Kessler, was at the CMA Festival and is able to step onto stage to chant of Bruce and perform with his buddy Darius. Unfortunately, Bruce can't carry his guitar because he hurt his back while designing a new demonstration for his Math 305 math modeling course. However, Big Red saves the day, allowing Darius to sing Wagon Wheel. So Big Red puts Bruce's guitar into a wagon and wheels it onto the stage. If Big Red pulls the wagon with a force of 55 pounds on a handle that makes a 20-degree angle with the horizontal, how much work has Big Red done if he pulls the wagon 50 feet across the stage? And so we know that the work is the dot product between the force and the displacement, which is equivalent to saying, it's equal to the magnitude of the force times the magnitude of the displacement times the cosine of the angle between the two vectors. And so this is just going to be 55 pounds times 50 feet times cosine of 20 degrees. And we get then that the total work is 2,584 foot-pounds. So, third problem that we have. Darius Rucker is getting ready to open the CMA Festival riding in a big red wagon, singing Wagon Wheel, when the wagon runs over his foot, causing the lead singer of Hootie and the Blowfish to break his leg. Fortunately, Big Red is there to save the day as he runs up to the stage carrying a 10-foot ladder. Big Red sets the ladder up next to the stage and starts to climb the ladder so that he can sing Wagon Wheel in place of Darius. Unfortunately, the ladder starts to slide out from underneath him, moving away from the base of the stage at a rate of 1 foot per second. How fast is the ladder moving down the wall when Big Red is at the top of the ladder 6 feet off of the ground? Big Red lands face first into the ground and is unable to open his big red mouth. However, Big Red has always dreamed of riding in a vehicle with Mr. Rucker, and he gets to live that dream with the two of them riding in an ambulance to the Vanderbilt Medical Center. Fortunately for everyone else, Dr. Bruce Kessler, WKU math department head, is at the concert. He steps on stage to sing Wagon Wheel and then receives chants of Bruce, like Bruce Springsteen receives at his concert. And so, one of the first things I tell my students in class is to draw a diagram whenever possible. So in this case, we're just drawing a right triangle. And so Things that are changing with respect to time, we label with variables. Things that are not, we can label with constants like the 10-foot ladder. And so what we're trying to do here is we're trying to find dy dt when x is equal to 6 feet, given that dx dt is 1 foot per second. Okay, so we use a Pythagorean theorem. We differentiate both sides with respect to time. I like this line just reminding the students that we're really using the chain rule here. And so this gives us then 2x dx dt plus 2y dy dt is equal to 0. So then what we do is you plug in 6 feet for y, 1 foot per second for dx dt. Then we use the Pythagorean theorem, plugging in y equal to 6 feet to find x at that moment. And x is 8 feet. It's a Pythagorean triple. And so then when we solve for dy dt, we get that it's minus 4/3 feet per second. The minus sign makes sense because the distance between the top of the ladder and the ground is continuing to decrease. And so if the distance is decreasing, then its derivative should be negative. Next problem that we have here is, oh no, while visiting his pal super mascot Rocky, Big Red caught Rocky Mountain spotted fever. Big Red was ticked off because if his temperature did not drop below 100.4 degrees Fahrenheit, he would have to stay in quarantine and not be able to attend Dr. Bruce Kessler's last concert as WKU math department head. The concert was 5 days after contracting Rocky Mountain spotted fever. Big Red's temperature profile for Rocky Mountain spotted fever was T of T equals 6.8 T e to the minus 0.5 T plus 98.5, where T is between 0 and 12. Capital T is the temperature in degrees Fahrenheit, and T is the time in days. Find the derivative. What was the absolute maximum temperature? At what time did that occur? What was the absolute minimum temperature? At what time did that occur? Was Big Red able to attend Dr. Bruce Kessler's last concert as WKU math department head? Explain, show your work to justify your conclusions. And so what I typically teach for problems like this is that you have a continuous function on a closed interval. And so we can use the closed interval method. The extreme value theorem guarantees the existence of an absolute maximum and absolute minimum. And then on top of that, that's going to occur either at the critical points or at the end points. So we have to go through and find the critical points. We don't have to worry about the case where the derivative does not exist. So we start by finding the derivative. This just illustrates the product rule. The chain within that, there's a chain rule of the derivative of e to the minus 0.5 t. This gives us a formula for the derivative of 6.8 minus 3.4 t e to the minus 0.5 t. When we set that equal to 0, what we get is that t is equal to 2. And so that's our lone critical point. And so then we plug in both t, 0, and 12 into our temperature profile. And this gives us 3 different temperature values. So the largest will be the absolute maximum, smallest will be the absolute minimum. If we go through the corresponding questions, find t prime. So this is our formula for the derivative. What is the absolute maximum temperature? Well, the highest of these temperatures is 103.5 degrees Fahrenheit. When does this occur? It occurs at t equal to 2 days. What is the absolute minimum temperature? This is 98.5 degrees Fahrenheit. It occurs at t equal to 0 days. And finally, was Big Red able to attend Dr. Bruce Kessler's last concert as WKU math department head? Well, we know that it's 5 days after Big Red got Rocky Mountain spotted fever. And so T of 5, and plug it in, we get that it's 101.3 degrees Fahrenheit. So since that's greater than 100.4 degrees Fahrenheit, Big Red was in quarantine and unable to attend Dr. Bruce Kessler's last concert as WKU math department head, to the disappointment of many, including Big Red himself. Okay. Oh no! Big Red's been modded, I tell ya! Normally, Dr. Bruce Kessler, former WKU math department head, comes to solve all WKU problems, like he has for the last 8 years for the Department of Mathematics, as well as he has for many years before that in the Ogden College Dean's office. However, he is on a well-earned vacation following 30 years of service to Western Kentucky University. In his place, Inspector Gadget arrives at 3 p.m. and immediately takes Big Red's temperature, which is 94.3 degrees Fahrenheit. 1 hour later, Inspector Gadget takes Big Red's temperature again and records a value of 93 degrees Fahrenheit. Inspector Gadget notes that the room temperature is 68 degrees Fahrenheit. When was the moita committed? Assume that Big Red's temperature at the time of the moita was 98.6 degrees Fahrenheit. And so this involves Newton's law of cooling, which is the following differential equation, where C is the temperature of the surrounding media. We assume that's a constant. T sub 0 is the initial temperature. And so to come up with a solution to the differential equation, one approach is to let P be equal to T minus C. When you differentiate that, dP is going to be equal to dt since C is a constant. That will give us the differential equation for exponential decay. The initial condition becomes T sub 0 minus C. And so we know the solution to exponential decay. When we back substitute in for T, we get then that T of T is T sub 0 minus C times e to the minus kt plus C. And so we'll use the solution of the differential equation to figure out when was the moita committed. So start by saying let n be equal to the number of hours after the moita was committed. This means then that T of n is going to be 94.3 degrees Fahrenheit. T of n plus 1 is going to be 93 degrees Fahrenheit. C is the temperature of the surrounding media. That's 68 degrees Fahrenheit. And T sub 0 we're assuming to be 98.6 degrees Fahrenheit. So I don't know if it's a great idea to assume that a mascot's internal body temperature is the same as that of a humanoid. Okay, so then T of n, we plug that in, subtract 68 from both sides, and we get the equation 30.6 e to the minus kn equals 26.3. Do the same thing for the next equation, subtract 68, and then we get, and so that gives us then, gives us the following. What we then do, what we can do is take the equations and divide them. When we divide them, the 30.6's cancel, and then we're left with an exponential where you're going to have minus kn plus k. The kn's will cancel and just leave you with e to the k equals 26.3 divided by 25. That'll give us that k is approximately 0.050693. We then plug it into one of the equations, solve that for n, and n is approximately 3 hours. And so, but we haven't answered the question yet. When was the moita committed? Well, the moita was committed at high noon because it's approximately 3 hours before 3 p.m. And so therefore we've helped Inspector Gadget figure out the time of the moita. And so unfortunately, Dr. Bruce Kessler was not there, but he was on a well-earned vacation. So we're appreciative of his time. And so again, I would like to thank Dr. Kessler for a great 8 years as our department head and supporting us in our many endeavors. As always, with any talk, we should have some references. And so for information about writing word problems, please consult me after the talk. For information about Dr. Kessler, please consult Dr. Kessler after his talk. Any questions?
That was a wonderful talk. I'm just going to say that. That was very good.
Very, very entertaining.
Thank you.
I got to tell you, I've actually, that problem you had with Big Red sliding down the wall, I've done that. I've done that problem. The problem is that you don't have a controlled rate of, it's gravity.
Yeah, well.
And, but it would be curious to, I'd love to know, I know how fast I was going when I hit the ground. I'd love to know how fast the bottom of the ladder, I need to work that out. Seems like it's pretty fast.
You're still the department head, so you still have time to figure out the problems. Huh?
Yeah, I can still work that problem.
So do we have any other questions? No. Okay.
Maybe in the future, I can get one of those questions in the videos, if you allow me.
Sure. I've got just a few word problems, so not all about Dr. Kessler. They're not all about Dr. Kessler, but in this, in this case, obviously it is. But
Oh no! Shocked.
Yeah, I usually do that in my Calc 1 class, and then I also do it in my differential equations class, and usually, people's heartbeats, it's a great thing to do at like 8 a.m. on like a Monday morning, and everybody's just kind of like, well, they're awake now, so I found a good way to get their attention, at least for one day. So.
Oh gosh.
Thanks for throwing me in those problems, man. That was great.
Sure, you're welcome. So, yeah, as I said, I wouldn't recommend in general writing word problems about your department head, but in this case, at least I tried to paint you in a better light. So,
yeah.
So.
Okay. Okay. Any other questions? Do we have any other questions? Okay. All right. Let's give our speaker another round of applause. Thank you, everyone, for for attending this talk. Okay. Anything else you want to say, Dr.? Okay. Anybody want to say something?
I think we all want to have some rest, right? Like the morning, right? I mean, since like 7
It's
a.m.
now officially the weekend.
And right before that, I get your heart rate up too. So.